I'll be talking about accelerating data science on C3 platform and how we achieve that. My name is Mehdi Maasoumy, and I'm joined by some of my colleagues here today that I would ask them to stand up and show faces so we can work with them and ask the questions if you like. So these are some of the data science members at C3, along with our product team, ML/AI product team. So please feel free to catch us for the remaining of the transform, and we'll be happy to work with you with any questions you might have. I would like also some brave volunteers to introduce themselves to get a sense of who is in the session. If you are a customer or if you're a prospect, if you could please just say your name, the organization you're from, the role in the organization, and if you're an existing customer or prospect. Anyone? Yes, please.
I'm going to fit into category C. I'm Steve Meyer, one of the co-founders of Kung Fu AI, respective partner for a services firm, and really interested in looking on customizing, extending the C3 AI platform, and also techifying a lot of our services. So we work with a lot of customers, and we have a lot of things in common. So excited to be here.
Super. Thank you, Steve.
Yep.
Anyone else? Back in 2018. That's right. Anybody else wants to? Yes, please.
Joe Gress. I'm with Ball Corporation Packaging Division. I'm the Global Engineering Sustainability Manager, primarily for electrical, but also gas and water. And we're in the process of getting stood up using the C3 AI product. I guess we've been working with C3 since 2020.
That's right.
On the cusp of actually getting data flowing into it.
Fantastic. Thank you. Maybe one more? Anyone else want to introduce? Yes, please, back there.
I'm the Chief Operating Officer for the global business for Plant Food Ingredients, Prospect, and
Fantastic. Thank you.
Simon for having us here.
Thank you. Thank you, and thank you, Simon. For folks who were brave, I have one more question. So, especially for prospects of C3 platform, I would like to understand, what are data science practices in your organization, the success stories from your team, and especially the pain points that you might be solving. Like, why are you here, right? There must be some pain points that you're facing today, either in terms of model experimentation, putting models in production, or scaling out AI applications, right? Anything that is on the top of your mind that you want to share with us? What brings you here and pain points? Yes?
And start with, where we are today is largely in terms of how do we transform our decision-making capacity for the organization, and what role does AI play? We are very rear view mirror, dashboarding, BI kind of company today. So how do you go much more in terms of predictions, in terms of ability to optimize in real time, in terms of really bringing the experience to the decision makers and much better quality and much uniform quality of decision making across. That's the rationale for why AI, and that's probably the problem points, and now they can be anywhere, whether supply chain or manufacturing or pretty much any area of our decision making.
All right, thank you. Jim Snobby also mentioned that, right? Not only in the boardroom, you want to look ahead, but also the rest of the organization. Any other prospects that are having pain points in scaling out their AI applications that want to talk about that? Is testing of your whole ML system been ever a problem? Data drift rings a bell for you guys at all? Model management? It does for some people. All right, so we're going to be talking about those just to set the stage. But in order to get there, let's look back. In the last 40 years in the information technology and in computer engineering in general, there has been these sort of defining moments and defining milestones that have been achieved. From back in the 80s, x86 instruction set architecture, to introduction of Java, to the advent of Hadoop and Mesos, which was essentially a precursor to Kubernetes, and most recently Spark. What's the common theme here? Just asking the crowd here. What do you see as a common theme here? Concept? Change is constant, definitely, yes. What else? Abstraction, wow, brilliant, spot on. Abstractions. So abstractions are very important. Why? Back in the 80s, x86 instruction set architecture was an abstraction for machine code. Java is an abstraction for interoperability of different OS systems. Hadoop is an abstraction for distributed file-based processing. Mesos is an abstraction for workload management. Spark is an abstraction for in-memory compute. And we probably need more abstractions going into the future. But why abstraction? What's the point of abstractions? Abstractions allow for separation of responsibility so that you can independently innovate in certain areas, abstract that away, abstract the complexity away, so you don't have to deal with it as you go and progress in your journey in the computer engineering history. So that's the point. And what's the benefit of abstractions? What do we get from introducing abstractions? Why do we need to have abstractions? Brilliant. Wow, we have a good audience here. Increased productivity. Increased productivity is a result of abstractions. And this is indeed what we have shown in the past. If you take C3 AI as an abstraction, that I will go into details of why and how much increase in productivity we get as we sit on top of infrastructure as a service cloud providers. We've shown between 18 to 26x improvement in productivity is gained. Can you imagine today that you had to train a large language model using punch cards? And how difficult that would be? Why can we do that? Thanks to abstractions. So abstractions are indeed the enablers for innovation in computer history. The reason we can have ChatGPT today is due to abstractions. So you guys all have been in the general area. You've seen this huge banner. This is enterprise AI. Have you wondered what is enterprise AI? What do we mean by enterprise AI? Let me take you through a journey to introduce what enterprise AI is. And I'll use a video game analogy here to draw analogs between the video game that some of us have played and still play, some of us. We won't say who. But also with respect to enterprise AI. In the video game journey, level 1 is easy. It's teaching you the rules of the game, how to play the game, and you're learning. You get quick wins, and you go to the next level. You know that there's a next level, and you know that the next level is going to be harder. And you're learning as you go. You're learning new tactics, you're learning new strategies. You're expected to fail at each step, at each level. Before you go to the next one, you fail so many times, and you learn, and you advance, right? This is all familiar to us. The other thing that is specific to video games is that you can't see what's next until you actually get there. So as you're in level 1, you don't know what level 2 looks like. As you're in level 2, you don't know what level 3, 4, 5 looks like. You don't know how many levels there are, right? Sometimes. And with each new level, the strategies that worked for you will not work in the new level. So whatever strategy got you to level 3 will likely not take you to level 4. You have to learn new things. You have to adapt. You have to learn from not only past mistakes, but also adapt new strategies to win the game. So with that, let's look at the enterprise AI journey. Just like video games, we have levels. So level 1, you train a model, right? Easy. We're learning the rules of the game. Quick wins, great. Life is good. But we know that there are levels ahead of us. We know there are multiple levels, 6, 7. Next level could be, now that you train the model, let's deploy the model and implement batch inference. Let's now use the predictions of this model on top of a Tableau dashboard and show it to the end user. That's level 1. Level 2, you may start to have multiple models, and you may need to, in order to manage your runtime for different models, containerize those models. You may want to be required to provide those as REST APIs. And version control and explainability might be needed from the end users. There are level 5, 6, and 7. And the question always is there another level? Level 5, you might have on-demand inference. You might have ML ops, model ops as a requirement. Drift detection. In level 6, you might have to essentially have support for shadow models, champion challengers, A/B testing. This is really getting hard now, right? We are at level 6. We're playing the video game at level 6, and we have to design a system that works with all these requirements. You may have dozens of models in production. You think there's a next level? I think we are pretty advanced at this point, right? We are pretty advanced here. Remember, in the video game, we always have a blind spot. We don't know what the next level is. Do you think we have a blind spot here? Probably. Probably there is one more level. Level 7, maybe another level, 8, 9, 10. It's getting difficult. So level 7, whatever you designed your system off of up to level 6 will probably not be good enough for level 7. You have now model lineage. You have to support model risk management. You may need to scale to hundreds of models in production. If we thought dozen model in production is difficult, how about 100 models? In level 8, you may want to introduce model training templates. It's a whole new concept. You didn't even know what model training templates are. Model monitoring and retraining within the application. Imagine having an AI application where you can go to the UI and train a model by the end user. Generative AI comes in, right, at level 8, and the user wants generative AI as part of the UI. And at level 10, you may have hundreds of ML AI applications. So we go from hundreds of ML models to hundreds of ML AI applications in production. So imagine that complexity. You may have industrial methodology for AI and ML and tens of thousands of models. We have customers who are playing at level 5. We have customers who are playing at level 8. And we have customers who are playing at level 10. Guess who is playing at level 10? So with Shell, we announced, this article is a bit old, 2022. We have 20 billion rows of data being processed weekly, 3 million sensors. We have, as of that time, 11,000 machine learning models in production. Now it's more. Richard can tell us what the number is. 16,000. So in the last year, this is very interesting. In the last year, we've added 5,000 new models in production. This article is from March 8th. What is today? Today is exactly a year ago. So 5,000 models trained in production within a year. So we are playing at different levels, right? Let's talk about these two foundational papers, which I personally found very interesting, and I really encourage you all to read if you haven't so far. They both happen to be out of Google. They bring up very interesting assertions, essentially, in terms of what are the requirements of ML/AI architectures and systems. The first assertion they talk about is that only a tiny fraction of code in many ML systems is actually devoted to learning or prediction. Much of the remainder may be described as plumbing. Sounds familiar? So 95% of the code we write for an ML system oftentimes is written to handle monitoring, feature extraction, configuration, data collection, and only 5% is truly devoted to learning piece, which is the core capability of our systems. Assertion 2, machine learning software systems are fundamentally different from traditional software systems. You wonder how they might be different. So in a traditional software system, you have code, and you have a system that you run the code on. In order to test this whole system, you need to have unit tests for your code. You need to have monitoring, system monitoring for the system that is running the code, and you need integration tests, right? But let's see what ML systems look like. What do you see as new components here? We see data, and we see model training. And as a result of introduction of these two concepts, we have to do way more testing, and in terms of unit functional testing and integration testing. We need to have data tests, we need to have a SKU test, data monitoring, we need to have ML infrastructure test, we need to have model tests and production monitoring, in addition to the existing tests that you have in your traditional system. So this talks to the complexity of the ML/AI systems and enterprise AI. One last assertion, consider ML training as analogous to compilation, where source is both code and training data. By the analogy, training data needs testing like code, and trained model needs production practices like a binary does, such as debuggability, rollbacks, and monitoring. So these all talk about how the beast that we're working with is something else. And there goes the need for a new abstraction layer. We believe C3 is that abstraction layer that is needed for designing, developing, deploying, and operating large-scale AI applications. Let's look at the current approach in most of today's enterprises. We all have clouds. We are all working on one of the 3 or more hybrid clouds, Google, Amazon, and Azure. And they're great. We love them. Without clouds, we wouldn't be here, right? Without cloud, C3 doesn't exist, and a lot of customers want to be able to do their jobs. But let's walk through what happens when you start running experiments, running projects, and writing applications on these clouds. So for each application, you start with a notebook for data preprocessing, right? You load your data, you transform the data into a better version, you dump it for future use. Someone else picks that data up in another notebook, does feature engineering. Another person or yourself later have another notebook for EDA. You have another notebook for model training, right? How do we test these steps of the way? How do we test different features that you have in the model in a best practices way as it's been proved in software engineering? And as you can see, for each step of the way, even for one application, we end up with this notebook underscore final, notebook name underscore final final, underscore final capital letter, underscore final final underscore VF, right? We've all been there. So As you can see, this is not the best way to build robust enterprise AI applications. So what do? C3 comes in, and we sit on top of the clouds. We provide these abstractions for data unification, abstraction for AI machine learning, abstraction for continuous data processing, for elastic compute. And the result of this is a set of either C3 AI applications or your custom AI apps or data science products that are built on top of this capability. But how do we do that? How do we not end up with that spaghetti of notebooks and models and so on? The approach of C3 has been completely different. We end up essentially providing ways to be able to have data pipelines which are reusable. Feature engineering and feature pipelines are meta-driven, reusable, persistent, searchable. Every component of the way, from data transforms to feature engineering to model training and model deployment, are metadata-driven types that are designed, documented, tested, and essentially are observed, and you're able to, with your colleagues, within the team, across different teams, collaborate using those artifacts. So the full reusability, a cohesive experience that is provided by this architecture, version control, composability. So composability of each of these components, from a feature to an ML pipeline, pre-processing and post-processing of pipelines, is a big enabler for increased efficiency. Logging, monitoring, and debugging capabilities are super important. You remember, in the new ML systems, we don't only have unit tests for code. We have tests for data. We have tests for ML infrastructure. So debugging needs to be easy. Debugging and monitoring and logging needs to be there, and all the testings that we talked about. So let's talk about how the world with and without C3 looks like. What's the current state of things, and what's the future state of things? What we have enabled essentially by this architecture is that today, your data teams and your data engineer and data science teams essentially, they're spending majority of their time on data preparation and feature engineering and on model governance, scheduling, and app integration. And least amount of time is really spent on where most of the value is, which is model experimentation and model development. So with C3 AI, the data scientists spend more time on the value add activities, which is, as we talked, the middle part, and less time on tedious tasks, such as data wrangling and scheduling. Why? Thanks to abstractions. They have been abstracted away and simplified. C3 AI provides out-of-box capabilities that the DS team are essentially manually designing today, such as the scheduling and API endpoints. Those are out-of-the-box capabilities for us. We unblock promotion of thousands of models with robust model operations and governance, a centralized registry, and a prepackaged model ops per user. These are the ways we are essentially allowing the users to spend more and more time on model experimentation. C3 AI enhances your cloud platform's data stores by providing data unification and virtualization. We enable artifact testing and reusability, as we talked about. So we can go into the details of, in each step of the way, essentially what are the steps where by which we enable this reduction and reallocation of the task, essentially, and reallocation of the time spent on task. I won't go through every single line here, but the idea is that, for example, on the data modeling part, if a C3 type is remapped to a different origin source, all the downstream analytics and applications are updated automatically. There is a single fetch command no matter where your persistent data technologies, thanks to that abstraction layer. There is in terms of feature engineering, which is one of my favorite parts, the expression engine library has very rich capabilities for outlier removals out of the box, for interpolation, for other operations, logical operations. All features are automatically stored as searchable metadata. So you might be familiar with the concept of feature store, where you store a version of the data. But here, what we have done is we go one step back and we store the definition, the metadata associated to each feature. What are the benefits of that? These are designed as objects that are composable. You can test them, you can persist them. Your colleagues can search and access those. They can compose those into more complicated features and essentially opens the way for collaboration here. On the model training side, we can recompose existing models as multi-step ML pipelines that are, again, objects that are persisted in the database. They're versioned. They are metadata driven. They are, again, persisted, and your colleagues can access them and work with them, enabling innovation and working together culture. We can quickly define model experimentation setups and train large number of models using the model deployment framework. Model explainability is provided off the shelf on these ML pipelines. And trained models are automatically registered for model management. So these are the ways, in fact, we enable that increase in productivity, right? That our colleague here mentioned, thanks to the abstractions. And on the last chunk of the work, we have scheduling, monitoring, application integration, which today our data teams, data science or data engineers, are spending a lot of time on. We are, again, abstracting away a lot of the complexity there. Jobs are backed by easy configurable resources that we can manage via a declarative language. Job history and statuses are logged for easy monitoring of the jobs. Model deployment segments allow deploying and monitoring models against the full population, a segment of the population, or per asset. These are some of the examples of how this increased efficiency and increased productivity is gained via the abstraction of C3 platform. So now I would like to open it up for some discussion. Any questions you might have, any best practices that C3 customers may want to share with the crowd in terms of how they're using these capabilities to achieve better efficiency and productivity in their teams. What is the composition of COE teams that are set up? And any other thing that you think might be good for the rest of the crowd to know. Existing C3 customers in the room, if you would like to share, please feel free to enlighten us. Richard?
So obviously we've got the sort of benefit of 5 years of working with C3 and scaling up our solution from where we started with a very small proof of concept running for 3 to 34 control valves now to 16,000 pieces of equipment across multiple applications, including optimization, integrity, and reliability. What we found was the initial start building up the capability in the COEs was starting off with, let's say, very sort of high-level qualified data scientists, and I'd say, Mehdi was actually one of them from the C3 side. So building up the skills and knowledge of the platform on C3 is an arduous task in itself. It's very foreign to most data scientists, because everyone comes and they go, what do you mean it's not Python? And you're not going to learn something that's based on Java. Why are we using Java as a basis for a platform? All the stories come up. So we found complementing the development teams, and we sort of created these pods which were generally made up of around 2 data scientists to 3, 4 app developers / data engineers for each application area we started off with developing. Supplement that with C3 staff to also, let's say, provide the deep understanding of the platform. Thankfully, I think through our experience, you've got a better set of documentation, you've got a slightly more performant platform, you've got tighter integration with Visual Studio. These things didn't exist in the beginning, so it really was a long journey to get there. Keeping that complement and really also ensuring that the data engineering piece is done well, because without that, everything else is secondary and fails. So the data scientists are all sort of the unicorns, also they think they are, but there's actually, there's still a heavy data engineering piece that still needs to be done. So we did that. We also worked very much in the DevOps sort of methodology, because at the end of the day, these apps have to be supported, and when something goes wrong, the question is it data availability, data corruption, issues on the platform, model issues, model problems, and we can't always put that back to one of the senior data scientists or PhD level data scientists. The apps we've built ourselves, we've also tried to, talking about abstraction, try to abstract the complexity of the data sciences from the application. So our remote operations monitoring team can actually create models and sit and put them live without having that deep understandings of stats models and techniques. And these we found would enable us to accelerate the growth and get more sort of models live, which ultimately returns the benefits in our space.
Thank you, Richard. So this goes back to, again, 2018 with that version of C3. This latest version are probably even better. But no, I think the idea is that the way we set up the COE in the beginning, I think there were 4 or 5 C3 employees and about 10 to 12 across 2 products, exactly. 10 to 12 shell data scientists and engineers. And at the same time, we were working on 2 applications. So in the first couple of months, 3 to 4 months, we not only trained these 12 shell developers and data scientists, but also essentially built from scratch the 2 applications that Shell wanted us to. And it was for me, it was a very fulfilling experience, and we hope to do that with many more customers. Anybody else who wants to share some insights? Or if there is any question, by the way, yes, please.
Can I ask Richard a question?
Oh, of course.
Sorry, pulled out Bank of America, also a customer of C3 for about 5 years. I'm just very curious whether, in your mind, it was from day one with C3 to today, it was very linear, or whether was there a growing pain period and then an acceleration, or was it?
It's steady. I would say in the beginning it was a lot of ups and downs. We ran into a lot of problems, and certainly at the time, so this is C3 at that time was a company of 180 people, 200 people max, with a lot of changes that have happened in the platform, very very poor documentation. To be honest, there was no source forge we could go to and sort of put out snippets and have a look. Even the community sites where it's scattered documented, which is where there was a heavy dependence on the C3 folks that had the experience on the platform and the knowledge. As we sort of developed the applications and built up the code repos and knowledge in-house, so we expanded. We're a team of around 50+ developers in Shell at the moment, and now working with external partners to build up capability for contract resources as well. So I would say it has accelerated. So we've gone through, we've probably got 8, 9 products in total in production now, running in C3. I don't know if you're in the panel with Shell folks earlier on, but in terms of the items that we investigated from a proof of concept or an accelerator approach that we sort of half or failed, there's probably another 15 of those to give us a look at. And there's another 5 or 6 in development at the moment as well. So it has got better and faster. We've also got a much wider internal Shell code RESTful APIs make a huge difference in able to integrate very quickly with other external systems. So, yeah, absolutely. I think it's grown a lot quicker. And now we've got a big support community internally as well. There's more new developers or resources coming in. So we're not starting from ground zero every time.
Makes sense.
Makes sense, but it seems like the size of the COE model in terms of like the scale, like
In terms of number of applications, at any one given time we've got around sort of 8 to 10 applications in development.
from day one.
No, from day one we started with the control valve for the maintenance to start with. And then 2 months into that journey, so just after we finished training the first group of people in the start development, we kicked off the work for sensitive consulting. So that sort of followed just shortly thereafter, and then the initial 2 applications. And then since then we added a number of other application areas covering sort of machine vision cases, optimization.
And you guys work with a lot of sensor data, so did you went into C3 with the virtualization phase where you virtualize the data?
That was a problem that we had in terms of our data book. So our historian that we use is from ISOsoft or Viva Client, which is a proprietary closed sort of data store. So we had to work on a method to get it out by into cloud store. So it was a separate piece of the program that we ran in parallel at the same time. Now we have that flowing through and sort of live streaming data that's populating, putting it in a data repository and ingested by C3, because we don't only use that data just for C3 analytics, as that's what other users in the show as well. But that in itself was a challenge. We talk about data structures and whether it's what you do today is relevant tomorrow's. The format of structure C3 kind of wants data into what we want for others. We're looking at how we can actually bring it all together in one single source, single format.
And so we can contribute as well, rather than just take. In terms of best practice, and speaking of abstractions, it's amazing listening to that panel earlier and to your comments, how pretty much everything that was said is exactly the same in our experience in the 5 years with C3. Apart from the precise, in product, our experience is like that down to almost every detail. So I don't know what you do with that, but.
No, I think Paul, that's reassuring here, and it's the same when we've had discussions with a number of other customers over the course of this last few days. And I think it's very much the same, same storyline that we hear from others.
The problem is the same in every industry, somehow, which is interesting.
Right. Thank you.
I think maybe another one maybe just to add as well. I think what made it also very difficult in the beginning is C3 decided to label certain concepts within the platform that contradicted with what is accepted elsewhere. Having to re-engineer people's brains or rewire them to think somewhat differently. That is changing, but now you're adding some more complexity with version 8. The platform kind of no one wants to know and work knows.
Yep, tasks.
Yes. Change is always there.
Features in V8.
Yes.
That was very confusing.
You have to leave some room for improvement, All right, thank you so much, everyone. We are at the hour. Thank you. We have to go to the general session area. Really appreciate your time. Thank you.